Hello everyone. Welcome back to Dr. Lou's VCE Physics channel. Today, let's learn together about the 2022 VCE Physics. We will focus on questions related to light as a wave. My explanations may need to be revised. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. The Doppler effect results in an increase in received frequency when there is relative motion towards the source and a decrease in received frequency when there is relative motion away from the source. Transverse waves travel in a direction that is perpendicular to the direction of their vibration. Longitudinal waves travel in a direction that is parallel to the direction of their vibration. The incidence angle is 45 degrees. The refractive angle is 90 degrees because it is total internal reflection. Using Snell's law, we calculate the refractive index of the glass. There are two waves between A and B. So, the wavelength is half of AB. Using the period and speed equation, we calculate this wave speed. Only transverse waves can be polarized. Longitudinal waves such as sound waves can demonstrate interference. The point C is bright because the path difference is zero, resulting in constructive interference. The dark band to the left of C has a path difference of half wavelength, which results in destructive interference. The experiment demonstrates interference. Interference is a wave phenomenon. The study design states that students must be able to explain the results of Young's double-slit experiment concerning constructive and destructive interference of coherent light. Many students refer to diffraction, however, the diffraction of Young's experiment is not found here. Students are expected to be familiar with the keystone experiments in physics. Both spacing of the dark bands and bright bands are calculated with the same equation. We substitute all values of variables into this equation and get the result. If the refractive index of the medium increases, then the velocity of the light decreases. If the velocity decreases, then the wavelength decreases. If the wavelength decreases, then the spacing will decrease. To calculate the distance aux, we must know the refractive angle. Using Snell's law, we calculate the refractive angle first. Then, the distance aux is calculated with trigonometric functions. The longer wavelengths, the larger the space between bright bands. The wavelength is from shortest to longest, blue, green, and red. A yellow light passes through a fine steel mesh, and a bright and dark fringe is observed. This pattern is not observed when the light passes through the open window. To form a diffraction pattern, the mesh must have tiny gaps for the light to pass through. Since no quantitative data is given in this question, the ratio of wavelength to wide is not required. The window represents a wide value much greater than the wide value associated with the mesh. Since the ratio of wavelength to wide is now much smaller, there will be much less diffraction. 5 multiple choice questions worth 5 marks. 3 short answer questions worth 18 marks in light as a wave. The overall score for this section is 23 marks. With a total possible score of 130 points, the percentage for this section is 17.7% of the total score. If you need my help, please add me on WeChat or WhatsApp, and send me an email. Thanks for your attention. Please note Dr. Lou's VCE Physics channel, Dr. Lou's VCE Chemistry channel, and Dr. Lou's VCE Biology channel.